Hi Trigonometry students, this is going to be our video that covers the material in class on Thursday. So I'm out of school at the UNL Math Day, but I'm going to get you started on our next section in the textbook, which is section 14.4. So let's go ahead and dive into the content from this section. So we're moving right along from section 14.3 into 14.4. So we went from work that involved solving identities, so simplifying them and verifying them. And we're going to move into work that involves solving equations. So looking for unknown variable values, just like we did back in algebra, in order to solve for unknowns. So we're going to take some of our identities material, and we're also going to take some of our previous work with inverse trig functions and with unit circle material. So today specifically is going to focus on work that involves the unit circle. So for those of you who like our unit circle material, this is going to take us back into that same land of reversing values to get ordered pairs. We're using ordered pairs to get angle values, things like that. So let's go ahead and take a look at this first example, example number 1. So it tells us that we're interested in solving an equation for x, and this is going to be an equation that happens to have a trig function in it. So we don't need to worry too much about our identities right now. So the things that we learned in the last section involving the Pythagorean identity, our reciprocal identity, our tangent identities, those ones won't come into play as much right now, but they will later on in this section. So right now we're going to just focus on what process do we need to use to solve trig equations and how do we work backwards once we've isolated values. So this tells us we want to solve the equation for x. And we're going to assume for the problems that we solve that we're working on the interval from either 0 to 2 pi or 0 to 360. So we're just working once around the unit circle. The equation that we're given is 2 times the cosine of x plus root 3 is equal to 0. And remember, our goal is to solve for x, so we need to try to get x by itself. So I can start getting x by itself here by subtracting root 3 from both sides. The reason I want to do that is then I'll end up with 2 times the cosine of x being equal to the negative square root of 3. Now, x is a little bit more by itself than it was before, but it's still not completely by itself. So next up, I would want to divide by 2. And then when I divide by 2 on both sides, the cosine of x will be equal to the negative square root of 3 over 2. At that point, the only thing that's left to do to get x by itself completely is to take the inverse cosine of both sides. So if I take the inverse cosine of both sides, the inverse cosine of cosine is going to allow me to get x by itself. So I can just perform this operation. These guys will cancel out, and I'll have that x is equal to the inverse cosine of negative root 3 over 2. At this point, you guys, that's an operation that you've seen before. It's been a little bit of time since we've done that. It's been since the beginning of what we did in chapter 14, the end of what we did in chapter 13. But this is just asking us to figure out, okay, what angle value has a cosine that's equal to negative root 3 over 2? So remember that your cosine value is all of your ordered pairs on the unit circle. So we want to go to the unit circle, and we just need to ask ourselves, where is there an x term equal to negative root 3 over 2? So we just go around looking at all of our ordered pairs, and the first negative root 3 over 2 that's an x term happens right here at an angle value of 5 pi over 6. So we can say x is equal to 5 pi over 6. And then we can keep going around to look for one more. The next one happens right here, and that angle value is 7 pi over 6. So those are going to be the two angle values that solve that equation. So if we plug those back in, that would make our equation true. So we've successfully solved for our first trigonometric equation. Now, there are a lot of reasons why we'd want to solve trig equations, but if you want to think about applications, think about all of the different kinds of things that we've graphed with trig functions. We've graphed art sales over time, we've graphed heights of waves, we've graphed information about circular motion, so Ferris wheels or jump rope. So anything that can be modeled by a trig function can be represented as an equation that you would want to solve. So you could ask yourself either when you're going to hit a specific value, so you think when you might hit a specific temperature throughout the year. So instead of just plugging things into trig equations, you can identify when those things happen. So that's what we're going to be working towards here. So that's our first example. Let me exit out and scroll on down to the second example so we can get another practice problem in there. So the next one that we're going to take a look at is going to be very similar to what we just did, in that our goal is going to be to get an x value completely by itself. So the next problem that we're looking at says 2 times the sine of x plus 4 is equal to 5. So just like before, our goal is to get x by itself. So we need to start removing things around the x. So let's go ahead and start that off by subtracting the 4 right here and subtracting the 4 right here. When we do that, we end up with 2 times the sine of x being equal to 1. And then to get sine of x by itself, we can divide both sides by 2. At that point, what we'll have is that the sine of x is equal to 1/2. So x is almost completely by itself, but we need to take the inverse sign in order to undo the sine operation. So I take the inverse sign of both sides. So inverse sine and sine cancel out, and we're left with the fact that x is the inverse sine of 1/2. So remember, if we go to the unit circle, sine represents the y value of your ordered pairs. So we really just come back to the unit circle and ask ourselves, where is y equal to 1/2? So as we go around, my first y being equal to 1/2 happens right here at pi over 6. So I can say x is equal to pi over 6, and then I can continue around the unit circle. So the next place, and mine's covered up by this menu bar right here, but you should be able to see the one fully on your page. And the next place that we get a sine of 1/2 is right here at 5 pi over 6. So those are going to be my two solutions. Now, remember, anytime you're interested in asking yourself whether or not you've found the correct solution to an equation, you always have the option to just go directly back into a problem and confirm the result. So these are the types of problems, just like systems of equations or basic equations back in algebra, that if you have enough time, you always want to check your work, because then you can verify whether or not you have a correct answer. So what I would try doing at this point is just pick one of your solutions, like let's say pi over 6, and plug it back in to this expression right here, so that you have 2 times the sine of pi over 6 plus 4. If you plug that whole thing into your calculator, making sure that you're in radians mode, you should end up with a result of 5. And so that will tell you that you have in fact solved for the correct answer. So we're just going to try 2 more of these examples in the next video, and then you can go ahead and get started trying some of these on your own in tonight's homework in our textbook.